Today we are going to solve longest subarrays of ones after deleting one element. You are given binary array nouns. You should delete one element from it. Return the size of longest non-empty subarray containing only one. Return 0 if no such subarray. So we are given a binary array and we are going to delete at most one. You should delete one element from it. So basically we are going to delete one element and we have to return maximum length such that the maximum length of consecutive ones. So we have to delete, we are not given at most, we are given exactly one deletion. So return the longest non-empty subarray. What is the one approach we can think is we can generate all the subarrays and subarray in which all are 1 except 1 which is 0. It will be our longest subarray. If no 0 present, we will simply return the array size -1 since we have to delete one element, but it will not be feasible since we are going our algorithm runs in order of n square time. So we have to think of some different solution. What we can think is since we have to deal with subarrays, so we can think of two-pointer approach or sliding window approach. So what will be our sliding window? Count of 0 is less than or equal to 1. In any standard sliding window problem, to get the size of subarray, we are doing r minus l plus 1. But here we are going to do only r minus l. Why? Because we have to delete one element. And if we delete one element, the size of subarray will be r minus l. Here we delete 0, so our maximum length will be 3. These 3 elements will be there and 0 we are going to delete. Here we are going to delete this 0, so 1, 2, 3, 4 and 5 total 5 element will be in the answer. Here we are going to delete any of 1, so the 2 ones will be in the answer, so our answer will be 2. So let's try to code it. Let's first of all take an integer n that contains size of the array. Let's take a counter. This counter will count zeros in given sliding window. Let's take another variable, max len. What will max len? Max len will be longest window with consecutive ones after deleting one element. So let's do while r is less than n, do r plus plus at last. We are checking if nums of r is equal to 0. If yes, we are going to increase count. We will check in while loop. If value of count is greater than 1, if yes, we have to reduce if yes, we have to reduce the size of windows. So basically we have to remove the first occurrence of 0. How we can do? we will check if nums of L is equal to 0, then we do count minus minus. Otherwise, or in all the cases, we are going to move our left pointer by 1. Until we remove our count of 1 reach to the 1, we are going to do this operation. Whenever our counter reaches 1, this condition becomes false and we break out from the loop. And here we update our answer. What will be our max len? Max of max len comma right minus left. And we have not defined R and L, so let's first define R is equal to 0, L is equal to 0. So let's try to run this. Okay, we have not returned our answer. It should be running fine completely. Yes, it is. So let's try to submit it out. Yes, it is working completely. So now talking about the time complexity, it will be at max order of 2n, which is as good as order of n, the linear time complexity, and our space complexity is order of 1. Since we are using couple of variables, it will not affect our space complexity much. So let's move to our second problem. Factorial trailing zeros. What is factorial? We are given the definition of factorial, we all know. So our problem is whenever do factorial of any given number, what is the number of last zero that occur? Like here, if n is equal to 5, factorial of 5 is 120. So here 1 0 is trailing. So we have to count trailing 0. In any number, when trailing 0 occurs, basically we multiply by 10. And how we are getting 10? 5 multiplied by 2. So in any factorial, we will count number of 5s and number of 2s. Number of 2s are available in larger amount, so we don't care about the number of 2s here. So our only concern is the number of 5. So let's suppose in 1 to 10, 5 contributes 2 times. 1 as 5 and 1 as 10, 5 into 2. So the trailing 0 in factorial of 10 will be 2. If we take 50, it will be 3. If we take 20, it will be 4. Why? Because 5 contributes 4 times. In 25, it will be 6. Why? Because in 25, we are getting 5 into 5. So 5 is contributing one more time. If we take 25 into 5, 125. So here 5 contributes 3 times. So we just need to calculate the contribution of 5 only. And how we can do? For any given number, if we do n divided by 5, it will give number of 5s which are contributing. But there may be number which are divisible by 25. So there will be another one. There are some numbers which are divisible by 125. So there are one more 5. And same way, number of ones are are there. So how we can get? First we will divide n by 5 and we will take the ceiling value, not ceiling, the floor value. The floor value of n by 5 will give contribution of 5. Now we are going to check the contribution of 25s. So how we can get? If we are getting the number of contribution by 5 by n dividing by 5, so we are getting just n by 25. How about n by 125? Contribution of 125, which is 5 cube, simply 125. And what will be the here? 4. And until when we are doing this? Let's suppose any power of 5 until 5 raised to some power k is less than equal to the given number, we are going to add it to our answer, right? So let's try to code it out. Let's take int answer is equal to 0 initially. Let's take a variable. Let's name it 5 while 5 is less than equal to n. What we are doing? Answer what we are adding to the answer? N divided by 5 basically, and we are going towards next power of 5, so we will multiply n by 5. What will be? And we just simply return our answer. It is as simple as that. Yes. So let's submit it. Yes, it is working completely fine. So that is it for today. Thank you.